Now we are going to solve some problem on the basis of principle of mathematical induction. The first problem is prove sum of n natural number, that is 1 plus 2 plus 3 up to n is equal to n into n plus 1 over 2 for all n belongs to natural number. So we are going to solve this problem on the basis of principle of mathematical induction. So first of all, in such type of problem we will assume or suppose, or we can say let P of n, because all the questions depend upon P of n. So let P of n is equal to 1 plus 2 plus 3 up to n, which is equal to n into n plus 1 over 2. So the step 1. What is step 1? That is, we will prove the result for n is equal to 1. For n is equal to 1, P of 1 is, here we will take left hand side. P of 1 means first element. We take 1. And in the right hand side, we put n is equal to 1. Or we can say left hand side, we will put here n is equal to 1. And in the right hand side, we will put here n is equal to 1 into 1 plus 1 over 2. That is 1 into 2 over 2. That is, we get 1. So we can see that left hand side is equal to right hand side. Then we can say that result is true for n is equal to 1. That is, P of 1 is true. So we will move toward the second step, that is step 2. In step 2, we will assume the result for k. Let the result is true for n is equal to k. That is, P of k hold true. That is 1 plus 2 plus 3 up to k elements. Result is k times k plus 1 over 2. That is, P of k is true. So as P of k is true, so by principle of mathematical induction, we have to prove P of result for P of k plus 1. So next step, that is step 3. So in step 3, we have to prove that result for n is equal to k plus 1. That is, now the second problem is prove 1 plus 3 plus 5 plus so on plus 2n minus 1 is equal to n square for all n belongs to n. So again, first of all, we will assume let P of n 1 plus 3 plus 5 so on 2n minus 1 is equal to n square. Now we'll proceed further. Step 1. for n is equal to 1. P of 1 will be true or false. We will check it out by proving left hand side is equal to right hand side. So first of all we will take left hand side. So we put n is equal to 1 in 2n minus 1. That is we get 2 minus 1 is equal to 1. And now right hand side is equal to n square, that is 1 square, that is 1. So we can see that left hand side is equal to right hand side. That is, result is true for n is equal to 1. That is, P1 is true. So, as P1 is true, we will move towards the second step, that is step 2. In step 2, we assume that is first, the result is true for n is equal to k. That is, P of k becomes 1 plus 3 plus 5 plus so on 2k minus 1 is equal to k here. Or true. That is, P of k is true. Now as P of k is true, so we have to prove in third step, result is true for P of k plus 1. So in step 3, we are going to prove, that is we have to prove that result is true for n is equal to k plus 1. That is, P of k plus 1 implies 1 plus 3 plus 5 plus so on, that is 2k minus 1 plus 2 times k plus 1 minus 1, replacing n by k plus 1 in the left hand side, which is equal to, that is n square, that is k plus 1 whole square. So we have to prove the result, that is P of k plus 1, 1 plus 3, so on, that is 2k minus 1 plus it becomes 2k plus 2 minus 1 is equal to k plus 1 whole square. That is, it becomes P of k plus 1, that implies 1 plus 3 plus so on, that is 2k minus 1 plus 2k plus 1, which is equal to k plus 1 whole square. So we have to prove this result. So proving this result, as discussed earlier, we will take left hand side, that is 1 plus 3 plus so on 2k minus 1 plus 2k plus 1. So as in step 2, result is 2 for 1 to 2k minus 1, and that is equal to k plus 1 whole square plus 2k plus 1. Sorry, it is k plus 1 whole square. No, it is k square. That is k square from step 2. That is, we get k square plus 2k plus 1. If we see that this is a formula of k plus 1 whole square, that is a square b square 2ab. So, it states that it is equal to right hand side. So, we can say that result is true for n is equal to k plus 1. That is, p of k plus 1 is true. So, by principle of mathematical induction, we can say that result is true for all n belongs to n. That is, Pn is true for all n belongs to natural number. So this was about the second problem.